Hi, this is Jessica Kintner. In this video, I'm going to give a brief introduction to classical mechanics. Mechanics is the branch of physics that is concerned with the study of motion. I remember, I used to think that was such a funny word, mechanics. I used to always associate it with cars, long before I took up the study of physics. But that's the word we use in physics to talk about motion. So whenever you hear mechanics, it means the study of motion. In this class, we're going to be even more specific. There's a whole lot of physics that deals with motion, and we are going to restrict ourselves to sort of what I might consider normal everyday objects. Things like the apple falling on Newton's head. If things start to get really, really fast, so here I've drawn a horizontal axis with speed, so V, you'll learn later, is the symbol for velocity, or speed in this case, it's just a magnitude. And c is the symbol that means the speed of light. So as speeds approach the speed of light, we need a different theory. For normal everyday objects, that's what we call classical mechanics. That's what we're going to be talking about in this series of videos in this class. And if things do get really, really fast, the name for that theory is called relativity. There's two theories you might have heard of: the special theory of relativity or the general theory of relativity. That would be something that we would study usually in a college level class. It's like the third semester. It's called modern physics, where you first get introduced to that, usually. Some books actually do it right alongside classical mechanics, which is actually really nice. We will not be doing that, so this series of videos is just going to concentrate on classical mechanics. Now I can also draw another axis here where size is decreasing as I go down. And when you get down to the level of atomic and subatomic particles, you need a different theory, quantum mechanics. So quantum mechanics is what we call it when you're dealing with the motion of very tiny particles. And I can actually fill in, there's a name for this fourth block here that's missing. If you have subatomic particles that are also moving very fast, the name of the study of that is quantum field theory. That is well beyond most undergraduate educations. Usually, even if you talk about a particle physics class at the level of undergrad, you don't usually talk about much quantum field theory. So for this class, for this series of videos, we're going to be smack in this area here, classical mechanics. I mentioned the apple falling on Newton's head. It's kind of an apocryphal story that everybody's heard of. Also related to that story is planetary motion. Newton's law of universal gravitation describes both how and why an apple falls, as well as why the Earth stays in orbit around the sun. So you notice there isn't, as we go up the axis, there's nothing above classical mechanics in the large direction. So even for planetary motion, we're still here in this region of classical mechanics. And indeed, most first semester college level physics classes do talk about some planetary motion, and we will as well. A couple more definitions just before we get started with the real physics. Kinematics is the word we use to just be a description of how things move, not why. It's the same root word as cinema, so motion, moving pictures. Kinematics is motion. It's a description of motion. The why things move, we separate that out in physics and we call that dynamics. So dynamics is a description of why things move, or a set of theories or quantities that are related to why things move the way they do. A couple examples of kinematics, quantities that I consider part of kinematics: position, velocity, acceleration. We're going to define and describe those in the next set of videos. Dynamical quantities are things like force, energy, and momentum. And in this series of videos, I will do kinematics first, and then we'll move into dynamics. This whole series of videos, this introduction works perfectly well for any level of mechanics. I'm going to use some calculus, even though not everybody's quite ready for that. I'm teaching this class assuming that students are taking calculus concurrently. If you've had some calculus before, that's even better. I will introduce some of the calculus that you need to be able to do the physics in this class. There's a couple reasons to do it this way. Newton invented the calculus to be able to do physics. It really helps. Having calculus at your disposal helps to do the physics. The algebra actually kind of gets in the way if you're stuck continuing to do things at an algebraic level only. Ideally, I'd have videos that cover both the same material at an algebra level and the same material at a calculus level. And someday maybe I'll get there. But for now, we're going to begin with kinematics, partly because the math. If you go on in physics, there's a whole upper division class of classical mechanics where you consider another set of theories called Lagrangian and Hamiltonian mechanics, still classical physics, but a more mathematically sophisticated way of tackling the same classical problems. But for now, let's get started with some definitions in mechanics, and we'll start with kinematics.